Okay, so I've spent way too much time on this last video, the last section of this video. And it's mainly because I get a lot of questions from viewers, but most importantly from my patrons, concerning how to do FM radio alignment. It seems like no matter how many you do, you still get questions. So I took some extra time, since this is such a simple type of tuner to do an alignment on, thought I would go through and do a couple different methods of how I align these things. And the instructions on this actually want you to do a sweep alignment, which is, to me, the most complicated way to do it. But I went through and did it, and then I showed you the way, that I normally do these. So I'm going to leave it all in there. I don't know how long this video is going to be, but it's going to be long. And most of it is going to be FM alignment. So all the other parts, if you want to watch through them, that's good. And I get it if you want to skip through the FM alignment. It kind of drove me batty also, spending so much time on this. I just want to get this off the bench and done because, again, I have so many other things I want to work on. And I've been really busy at work on top of that, so I have only been able to spend an hour here, hour there at the bench. And so this has taken a lot longer than a normal video would take to do. So I hope you enjoy it. I hope those of you who are interested in this sort of thing get something out of it and learn something. And those of you who are looking for something else, well, it's in this video too. So you can watch the things you like and not watch the things you don't like. So let's get started and I'll let you check it out. Okay, so I was able to find a replacement volume pot for this, thankfully, and it fit right in. And here's the old one taken apart. Now, when I said these things are peened over, you can't repair them. What I mean by that is when you take the back cover off, which that comes off pretty easily by bending the 4 tabs, and this pulls off. But this shaft, now see, in some pots, when you look at this, if you push up, there's a little gap in there. On some of those, there will be a little clip that you can pry up and then pop out. And then this part of the shaft right here will actually be a smaller diameter than the neck here. So it will pass down through. So the whole thing just comes apart like that. On this one, it's not like that. This has that flange on there, and it's physically smaller than the hole there. So it won't go past that. You can see there's a little tensioning ring that you put in there, and that pulls tension on there and acts as like a bearing surface, but that's it. But on the back, you can see this is peened over here. That's what I mean by when they build these, they stack all the parts together, and then they put this plastic piece on the back with this wafer board stuff, and then they peen it over, kind of like it makes this rectangular shape. And you can see I tried to grind it out a little bit with a Dremel, but it's so far down in there. And you can see the dimple in the middle. It's actually kind of like forked when they push them up through there, and then by peening them over, they squish them down into there, and that puts tension on this, and that's what holds the fingers onto the carbon elements and everything. So it's really hard to get one of these apart, long story short. And this plastic is what broke. And you can see where it snapped off in here. Because of that, there was a little piece that stuck out, and that would go around, and that's what would hit this little bump stop right here. See that right there? Kind of hard because it's not focusing. And when that part snapped off, it allowed this pot to go, when you turn the volume down, it allowed it to go past the end stop and get caught in there. And that's what broke these little fingers, messed up the pot. And I'm not on frame here. So, long story short, these are very difficult, if not impossible, to repair. I suppose if you wanted to have the patience to grind all the way down and take that out, you probably could repair this, and then you would have to somehow attach another little tab to stick out from this plastic piece that would hit that bump stop. just wasn't worth it to me. It's easier to just find a replacement potentiometer. That was a 50K stereo pot. Those are very common for transistor stereos. The only thing you can be a challenge is the loudness tap. And you can see that tap is connected about 2/3 of the way over, maybe a little bit. And that's for the loudness contour to work. And some of them, this pin will be, there'll be a wire coming down the side, and there'll be a 4th pin down here. So those ones, you have that type, and then you have the one with the loudness tap coming out the top. Those can be a little tougher to find because this is kind of an old design. But they're still out there. You can find them if you dig around enough. You just have to watch whether you have the knurled shaft or the D-shaped one or whatever for the knobs, so that the knobs will fit properly. Anyway, enough about that. We're now to the point where we can start looking at the alignment. And the first thing I'm going to do is the amplifier alignment. That's the easiest part. And we're just going to adjust the idling current. And all that, and that's all this has. This does not have a DC balance or DC offset adjust. So whatever that is, it is. You just have to have well-matched transistors. If one of them is too far off from the other, you can have a little bit of offset on there. And a little bit is going to be okay on these small amps, but if it's too much, you pretty much have to replace transistors. That's where you're going to be with that. So first thing we have to do is go on the bottom of the chassis, which is kind of goofy, but that's how you do it. And pins 1 and 3 on this tag board down here, and then pins 5 and 7 for the other channel. And so we're going to start out by turning the amplifier on. We'll plug it in. And I'm just going to go full power now because it doesn't matter. We know everything's working now properly. And I want to let this warm up. Whenever you do DC offset, or the offset and the bias, you want the transistors to be kind of at their idle operating temperature, and that usually takes about 10 minutes. So I'm going to hook up these wires to 1 and 3 for starters, and then I'm going to wait until it stabilizes a little bit, and then we'll come back and we'll actually do the adjustment. Okay, so I'm connected to the first set, the first channel, and you can see in the instructions they want it to be about 15 millivolts. And right now we're high. It's 25, so we want to turn that down. And if you look on the board on the other side, so this would be this board here, but on the opposite side, you have these two pots here, VR601 and VR602. 602 is going to be the one for these pots here, or for these test points here. And if I move this around, you might be able to just kind of make out where they are. You can see there's the one and there's the other, and I'm just going to adjust those. I'm going to put this back in position where you can see the meter, and I can reach, and let's see what we come up with. So I'm going to use one of these ceramic screwdrivers. You can buy these online, like eBay and Amazon type places. They're pretty cheap. You can buy sets of them, and they're nice because they're non-conductive. So if you touch something metal, you're not going to short it out, which is always a good thing. So let's go. And the good news is this pot seems to be in very good condition because it's adjusting very smoothly. There we go. That's close enough. And that'll drift up a little bit as you run the amp harder, and it heats up. It'll go up a wee little bit. We'll just touch it a little more. See if we can, there we go. All right, I'm going to leave that one alone. That's pretty close. Again, as this amp heats up even more, it'll drift up a little bit. So now we want to get on 5 and 7. So there is 5. And here is number 7. And you can see that one's a little bit low. So we'll bring that one up. Am I going the right way? There. Oh, too much. This one's a little harder to reach, believe it or not. And there we go. I'll take that. And again, this is not super duper critical. You just don't want it to be too much higher than what they recommend, because they recommend these already a little bit on the high side to compensate for any differences in the transistors. But quite often, the transistors are more well matched than the worst case scenario. So if you have decent transistors in there, you can usually go a little bit lower and the amp will run a little bit cooler, and you'll still have good distortion figures. If the distortion level is still a little high, you can increase that ever so slightly and it should lower it back down. But this kind of prevents crossover distortion. That's what this is all about. I've talked about that pretty much on many other videos. All right, so we're just going to let this sit around for a while and make sure it's still good, and then we'll come back. Okay, so here's the setup. I'm going to just use my fluke meter, and believe it or not, you can do a pretty good job without an analog meter doing these alignments. The problem is with analog meters, like a volt-ohm meter, like a Simpson 260 or the triplet or any of the cheap little analog meters, they cannot read AC voltage down low enough to be able to get a good scale reading. So what you need to do is you need to have an AC meter that can read millivolts. They have you test it at the output of the record output jacks. So you can see I have just a RCA jack on the back going to the tape out, and it's going into my meter. And you can see, since the fluke meter and most digital multimeters can read down in the millivolts of AC voltage, you should be able to see something there. So that's where we are. For a signal generator, right now I'm just using the HP. You can see there it is. And it's just set to 30%. They want 30% modulation, 400 hertz modulated at 455 kilohertz. And you just have to drive enough signal in there. In this case, I'm driving about 12 millivolts, and that's what it takes at this test point. They have you inject the signal onto test point 2 on the AM board, which is right down here. And you have to couple it through a 0.01 microfarad capacitor. So that's what we're doing. So there's the setup. And all they're going to have us do is peak the IF coils, which is T204, 203, 202, and 201. So there's 4 of them, and we just want to max out the reading on the meter. So that should be pretty straightforward, right? So let's get everything set up. Okay, I think I got everything where we need it. And T204, 203, 202, and 201, and that's these 4 right here. And I don't think they give you a diagram. They give you a diagram for the FM, but not for the AM. But this one's going to be your oscillator, and then these ones are going to be your IFs, I believe. So I'm not going to touch this red one because that's going to be your oscillator. Usually they're color coded, but you never know. So we're just going to start with these yellow ones. Actually, they want you to work your way back, so I'll do this blue one. And what I'm going to do is, before I start, I'm just going to put a little mark on these so I know where I started. That's always a good idea to do. because if you get yourself really messed up, you can always put them back to where you found them. And in this way, you just use a little permanent marker like that. And if you want to clean it back off because you're OCD at the end, it's easy enough to just go ahead and get some alcohol and wipe it off. So anyhow, so let's start here, see what happens. That's definitely not it. Oh, look at that. We got a little bit out of it, right? And we can listen to it. It sounds good. Okay, so let's go to this one. We're just looking for the biggest number. Now, I don't know now, that might be, no, it's still good. Wow, that was way off. Hold on, there. Huh. Right about there. Yeah, that one was off a little bit. Okay, so let's move this one now. Nope. That was a wee little bit off, right? Right about there. And then this last one. Wrong way. This one was pretty much on. Okay, so we got a good bit out of that. So this middle one here was off a little bit. Very good. So let's turn that down, that's annoying. Okay. Connect a short loop of wire. You can see I'm reading this. Radiate the signal into ferrite loopstick antenna. So we just want to do our little loop, which is this right here. I'm going to disconnect my capacitor from there. And I'm going to connect my radiating loop. Hope you see what all I'm doing here. And I'm just going to pull the antenna up like this, kind of at an angle. Just hang the loop on there like that. So now we want to go to 600 kilohertz. So I'm going to do frequency 600 kilohertz. And I want to tune the dial to 600 kilohertz. And then we want to adjust our oscillator coil and our antenna ring, which is this middle thing here on the end. So let's turn this around and I will dial this in to 600 kilohertz. I don't know if you can see it from this angle, but I'm going to go down to 600 and right there. That's pretty good there. But what I want to do is I want to put it right on 600. So that's where it's tuned in. And it is very close. Very, very close. But I'm going to put it right on 600, looking straight on. And then I'm going to move this back around. And if you turn it up, you can hear it's still good, but it's not totally on peak. So now what we're going to do is we're going to adjust for the maximum reading on the VTVM again. This time we're going to do that red slug. That is the actual oscillator, and that's what controls where the dial pointer is going to be on the scale versus the frequency. So it's just probably just the tiniest little bit off, so we should be able to peak it. That's the wrong way. It's very, very touchy. That's pretty much how these work. 202, 207. Well, it's getting there. I think I'm going through the peak now. I am, yes. Right there. Right about there. We're right on. That's about as close as you're going to get. And if you look, when I'm done here, there we go. And I don't know if you can see from here, but I'm very, very close. I barely had to touch it. But it's just, the slot is just barely on the other side of my little reference mark. So that was very, very close. Now we're going to go to adjuster here on the end. And we're going to turn this. See how we're going right there. I'm not going to touch it anymore. And you're just rotating this one. Now some of them have an actual slug in the end. This one doesn't have it. You turn the whole thing in here, I believe. You can see that's pretty good. Okay, now we're going to go to 1.4 megahertz or 1400 kilohertz. Frequency 1.4 megahertz. And we're going to tune the dial straight on to 1400 kilohertz or 1.4 megahertz. I'm going to do that again over here. And I should be on. And off a wee little bit right there. See here? So I'm a little bit off. So now we want to adjust. And they have the CT5 and CT4 on the front end. So here's CT5 and here's CT4. So if we line this up the way they're showing it, 5 is the one on the bottom and 4 is the one that comes from there. That's your antenna trimmer. So let's look at that, and I might need a little heftier screwdriver. We'll see where this is right now. So here's our oscillator. Now here is going to be crazy sensitive because these little adjustment screws are just way off, like really touchy. And sometimes it's better when you're listening, so let's listen. I'm going to shut this light off here. Do you hear that, like when you go through it? Right there. And that's kind of a noisy adjustment, so I'm going to clean that off a little bit. Nope. About 204 is where we're kind of peaking out. Yeah, 204. Right there. And of course, as soon as you let off, because your hand is putting a little bit of pressure on it, it moves. So you have to kind of compensate for that. That's wrong. See how touchy this is? You just have to play with it till you get it right where it needs to be. There it is. Okay, now we're going to do this top one. And it's not going to be as dramatic. You can see how I'm moving it quite a bit, and it's making just a little bit. Oh yeah. That's quite a bit off too. Okay, went back through it. That's it. Okay, there we go. Your tuner's done. That's all there is to it. It's very simple for the AM. Now it's time to do the FM. Okay, it's time to do the FM alignment. And for the alignment on this particular model, they are doing the dreaded sweep alignment. So many folks are so terrified of that because it can be really confusing what they're talking about if you've never seen or done one. And I've done this multiple times on this channel, but I'm going to go through it one more time and I'm going to kind of show you some of my tricks that I use. So the first thing we're going to do is you have to have an FM sweep generator. Another name for that is a wobulator. I love that name. But I digress once again. So what we want to do is you're going to take a sweep generator and you're going to connect it between the junction, at the junction of C913 and 912. I don't know why they make it so confusing like this. I marked it on the schematic to make it a little more understandable. And if you look down here, all they're saying is pin 1 on the IF board, which is the IF input. See right there? And right there's 912, C912 and C913. See them there? And that's where they join. And it goes right on pin 1. So why don't they just say pin 1 of the IF board? Same thing with where you're going to put your scope. You are not going to use a scope for this. Since we are using a sweep generator, we're actually going to connect the sweep generator to this test point, and it's R127 and C126 junction, which once again, I don't know why they said that. Here's R127, here's C126. It's the multiplex output. All this is your detected audio, and that feeds into your multiplex. So pin 5 of the IF strip board is where you're going to put your measurement. So pin 1 and pin 5, that's all you need to know. If you look on the receiver here, you can see pin 1 and ground are right here and here. Those are the inputs, and this is the input of your IF. Here's the 4 IF transformers down here. And the output is the pin, which is that pin 5, is the one with the yellow wire on it. You can see right there. See that yellow wire? That goes down into the multiplex board for the stereo. I just connected that on there. Now, different sweep generators will have different probes and different ways of connecting. I'm going to show you how to use the Sencor SG80 because it does have a sweep and marker function where we can actually produce a sweep signal and markers. But I will tell you it does have a couple things that I don't like about it. It's a pretty rudimentary sweep generator. I much prefer this one over here, which is my Payco G32, and that's a sweep generator with marker adder. I love that. It does a beautiful S-curve. But we're just going to use the SG80. So here's the SG80. If you have an SG165, which a lot of you out there, especially my patrons and so forth, have those, it's a similar thing. It's a little bit different. The detector probe and everything is a little bit different, but if you understand this, you'll understand the SG165 as well. They're close enough. But the first thing you want to do is you want to set it to sweep. There is a little built-in marker generator for 10.7 megahertz, and you can actually adjust that marker so you can change the frequency of your marker. I'll show you what all this is here in a little bit. And then you're going to hook your scope up in XY mode, okay? So you've seen me do that before with other videos, I hope, if any of you who watch my channel. But this goes out to the X and Y of your scope. And then this is a special detector probe that has some diodes and capacitors and resistors in it. It's just that little probe down here. I'll show it to you in a second. And that's the thing that you actually connect to the test point. This is what's going to pin 5, the output. And this is what's going to pin 1. This is your signal out. So this is the signal output. This is the detected signal input. And it goes in through the SG80, and then it adds the marker and then feeds the signal out as an XY signal into your scope so that you can generate that S-curve. Now, when everything's hooked up, and let's look at the probe for a second. If you buy an SG80, make sure it comes with the probes. You can always build these. They're not very difficult to build. You can see how small it is. There's really not a lot of components in there. But there is a few things in there, like a diode and a couple of capacitors and a resistor, I think, something like that. They're all similar. Every sweep marker generator has a similar kind of situation like this, one of these kind of probes. I'm using the isolated input. This is a detector input. This would be if you connect it before your detector. This is like a built-in detector. This is where you're actually looking at the detected output signal. So this is the one you're going to use to get your S-curve. And then you connect the center ground to your ground. So that's how this connects. You basically have an injection point and then a readout point. And looking again at the schematic, you're just looking at here's your detector right here. See this is called the ratio detector. And these two diodes are what actually detect. They strip away that 10.7 megahertz IF frequency and only allow the audio to pass through. So by the time it comes out here, it's just detected audio mixed with your multiplex signal. So if it's a stereo station, you also have your multiplex signal riding on top of that, with your detected mono audio. I have a whole series of videos where I've shown how multiplex FM stereo works and what a multiplex carrier is and so forth, and how they get left and right derived from it and how all that. But anyway, so I'm not going to repeat that. So we're going to inject a signal of 10.7 megahertz, but we're actually going to sweep it above and below 10.7 megahertz, and we're going to do that at a rate of 60 hertz. So a sweep signal has two frequencies. It has the frequency of the signal generator, and then it has a rate at which you're varying that frequency up and down. So in most sweep generators, all the old ones, that one I just showed you, the Pico, this one, that sweep frequency is either going to be 50 or 60 hertz, depending on your line frequency where you live. So over in Europe, it'll be 50 hertz. Here, it's 60 hertz. So all it's doing is it's varying, kind of like a ramp, like a triangle signal, up and down, above and below that 10.7 megahertz, 60 times per second. And that's what you're injecting in here. Now, why would you want to do that? The reason you're doing that is after you peak everything out, okay, you get the biggest signal you can to pass through that 10.7. When it gets through here, anything that's above 10.7 megahertz is going to get clipped off, and anything below 10.7 megahertz is going to get clipped off. But it's not real sharp. It kind of rolls off. And the idea of a sweep alignment is as that 10.7 megahertz, you're actually going to put a marker. And in other words, you're going to put a 10.7 megahertz as another RF signal that's fixed at 10.7. And whenever you pass through that, you'll see that little pip there. You'll see like a little zigzaggy line, and that's where when you're sweeping through the 10.7 megahertz and then it lines up with the fixed 10.7, you'll get like a peak there. And the idea is where that little pip is, you want it to be in the center of that sweep, because what we're trying to do is if you're riding on 10.7 megahertz, your audio is doing the same thing as that 60 hertz. It's going above and below 10.7. And of course you want it to be centered. In other words, you don't want, like, your audio to swing more to the positive direction than the negative, or vice versa, because that's how you're going to get distortion, because you're going to get asymmetrical clipping, just like when you work with an amplifier. So what this is doing is it's allowing you to center that in that sweep area. So you're actually watching the modulation of that 10.7 megahertz intermediate frequency, if that makes sense. I'm probably confusing the hell out of some of you, but in a nutshell, that's what we're doing. So I'm going to show you that on the scope here now. Okay, looking at the scope, you're actually looking at what we call our S curve. And remember I showed you that knob next to where all of the oscilloscope connections were? It said marker height. If I turn that down all the way, you can see I get this straight line in here. See that? And when I move my hand near the signal generator, it picks up my, it capacitively couples my body to that. That's what that was. But if you look along here, you get this nice slope, and that's what you want. You want this S curve to be a straight line at an angle. See that slope? Now when I turn the marker up, like so, you can see that there's that little pip there, and then there's one on the top and one on the bottom. And the idea is you want to get that top and bottom to be in this slanted area. So you want a nice straight line. You want this to be as tall as possible. That's what you're doing when you adjust the IF cans. And then you want that little pip and these two secondary pips on either edge to be in this area here. If it's not, that's where you start getting distortion. Now, the one other thing I really hate about the Ascendcore SG80, see this ugly line running through here? That's called a retrace line. And what that is whenever the signal resets, remember how I said it's 60 hertz? Every time the trace stops here and goes over to here, since we're in XY mode, the trace just follows over there and then does its thing again, and then comes up here and traces back. Well, a good sweep generator will actually blank the output when it resets. In other words, there'll be like a little pause when it resets back to here, and then it'll sweep again. So you don't see that ugly retrace line. I hate that. So what we're going to do is we're going to do something to make it disappear. Okay, you ready? 1, 2, 3, gone. All right, so how did that happen? How did I do that? So this is a little box I made that its whole purpose in life is to get rid of that ugly retrace line on signal generators that don't have a blanking signal. This basically generates a blanking signal. So you feed the signal generator into it. These are tied together. These are in parallel. So basically this and the scope, it's just like connecting this straight to the scope. But what it's doing is it's picking the signal off that's up here on these, and it's creating a blanking signal that you're feeding into the back of the oscilloscope. Most oscilloscopes, usually on the rear of the scope, it's not on the front. There's another BNC connector called Z, okay, your Z input. The Z input is your brightness input. If there's nothing connected to it, normally, what's how that is, the brightness is controlled by your brightness control on your front of your scope right here. See that? So, you have your intensity. I can turn it up and down like that. But if you put a voltage anywhere from 0 to like about 5 or 6 volts into that Z input, the higher the voltage, the closer you get to 5 volts, the more it blanks or dims the trace. So if you put 5 volts here, it'll basically turn the trace off. If you put 2.5 volts, it'll darken the trace, it'll dim the trace to about half brightness. And what this is doing is this is creating a blanking signal that every time it goes to retrace, it puts a pulse out of here that basically tells the scope to shut the trace off while it's retracing. That's what this is. If you're interested in it, maybe that'll be another video. Let me know in the comments section. I'll show you how to build one. It's a very simple circuit, and it works. As you can see, it works perfectly. Now, does it matter if you have the retrace line? No. It just makes it a lot less annoying. I can't stand seeing that ugly line on there, so that's why I built one of these. Okay, so when you're doing a sweep alignment, this is essentially what you want to end up with. Now, on the SG80, if I turn when you turn the marker up, there's multiple markers that it introduces. This thing's designed exactly for FM alignment, whereas some of the other ones are called TV FM marker generators, and you have to kind of provide your own external markers and things. I won't get a whole lot into that, but just know that the SG80 is good for that, even though it doesn't have that blanking signal or anything. Now, if I turn the markers off, let's say I just rotate the marker height all the way down, you're going to see this S-curve here. And I like to set the S-curve using my positions here so that the center of the S-curve passes the crosshairs here of your graticule marks on the scope. See that? And I want it to be kind of an equal height on either side. And the idea is you want this to be a nice straight slope here, intersecting kind of at an angle. And you want the top and bottom to be kind of symmetrical. Now, you're not going to get that to be perfect, but this is actually a pretty good one right here, what you're looking at. But we're going to see if we can trim it up a little bit more. So let's turn the markers on. And when you turn the marker on, your 10.7 is the biggest pip. You can see there's a couple smaller ones, but the biggest one is going to be your 10.7. And it should be right there at the center of this sloped line here. And it is, as you can see. And that means that right now, you know, when your audio is swinging up and down, you know, above and below 10 megahertz, because it's FM, you know, 10.7, you have the full amount of this swing area. And you can see these side markers are kind of showing your side bands of that, like the extreme, you know, the end of your deviation, let's say. And you want those to be about the same distance, you know, from where it curves on each side. So see how this one from here to here and this one from here to here is about the same distance? That's what you want. Now, going over to the adjustments. The last can here, closest to where we're picking up the signal to measure it, this is your detector circuit right here. So this is where you're adjusting your FM detector. These three up here are the actual IF filters, or your IF transformers. So these are what are actually, you're centering these to the 10.7 megahertz peak, and then you're using this to remove the audio signal from the 10.7 megahertz. And you want it to do that in a symmetrical way. So what we're going to do is we're going to start with the detector, believe it or not, and work our way backwards. So this top one is going to have the most influence, and that's also what's going to set your tuning meter to be on the center. If you get this right, what should happen, let's see if I can move the camera, the tuning meter should be centered. If it's not centered, then you have something wrong in your alignment. So this should correlate with that pip being at the center of that slope. If it's not, then you have a lot of alignments that are out, like somebody was in there tweaking on it. Normally it should be pretty close to this, and you'll just, you know, you just touch it up a little bit. But if somebody doesn't know what they're doing and they go in there and they start cranking on these, especially if they try to align this off of an FM radio station, for instance, and tune it by ear, it's never going to be perfect. You can get it close, but it'll never be perfect. The other thing you're going to find out is this is an analog tuner. So as the tuner warms up, that's why you have to let this sit for maybe 15 minutes before you start any alignment. Watch what's happening. You can see how this has grown a little bit since just in the time we were talking, because I just set this up and turned it on. And you want everything to settle kind of to its operating temperature, because it will drift slightly. It won't drift as much as like some of the old AM tube radios and things will, or the FM vacuum tube radios, but it will move a little bit. Remember, this is not using synthesized tuning or anything. This is an old oscillator-based analog tuner. Okay, so let's start with the detector adjustment. Okay, and that's the bottommost transformer I showed you, and I'll show you what the top of the can does. And you can see what it's doing is it's moving the overall, it's stretching it, and they tell you to make it for the maximum peak is what it says in the instructions, but that's not really what you want. You want to set the detector so you're right there like that. Even without the 10.7, you can see we're intersecting the middle there. And when you turn this pip on, it should fall right on top of that. When we're done, that's the goal. Now you can see these other markers here up, and we want to set those. This has to be halfway between here and here. And this one has to be halfway between here and here. And this marker needs to be right at the curve, and this marker needs to be right at the curve. And we're pretty close right now. So I adjusted the detector. Now I'm going to adjust the bottom part of the detector. And I'm going to have to reposition the camera so I can get around here. Okay, you might see my head come in here for a minute while I get the alignment tool in there, because I'm now on the bottom of the receiver. And let me get on the adjuster. Let's see, it's a little tricky to get the... This one has a slotted instead of a hex adjustment, so it's a little tough. There we go. And you can see when we move that, it stretches it. And the idea is you want this to be symmetrical, and you want these to be pretty close to the curve, and they are. And you can see I can't really get it any better than that. So we're going to just kind of see, and if I go this way, this starts climbing up this way. If I go this way, so we want it to be just about perfect there. And you can see it's not symmetrical top to bottom. So we want to have about the same amount from the center on either side. And you can see, there we go. That looks pretty close, which is where we started. Okay, now we're going to go over here. I'm going to go and just do this one, then the one up above, the front and back of the top and bottom of each one. So I'll do this one first, then the bottom of this, top of this, and the bottom of this, and then top of the last one, bottom of the last one. So let me get you back on here. Okay, I know this is kind of at an angle here, but I think you should be able to see it okay. So now we're doing third IF. And you see when we adjust that, that kind of shifts everything over a little bit. See that? And again, it's pretty close. Right there's kind of where I want it. Can't go too much more or it'll start distorting. So that's good. Right about there. And I'm going to go to the back, or go to the bottom, I should say, of the transformer and do that section. Let me get it's tough to get this tool in here. Doing it by feel here. Okay. And you can see that they all kind of adjusted in a similar way. See, I don't want to move that. See, these are right on. Okay, now go to second IF. And see, that's going to adjust this a little bit. And I like that. actually improved it a wee little bit. And then I'll do this a little bit more. This is the back side of it, or the bottom, however you want to word it. Just like that. And you can see we're getting a little bit different here, but it still looks good. We'll trim it up here in a minute. And then now we're to the first IF. And that should, see, that doesn't have a whole lot of influence. It kind of adjusts to the roundness here a little bit. You just want to kind of peek that out a little bit right there. And then the bottom part. Okay. And let me get it in here. Okay. Go like that. And then that looks really good. So now what I want to do is I want to just kind of bring it back in a little bit with the detector. It's ever so slightly off. So I'm going to bring it back to center. Kind of like that. And that's about as good as I can get it. And you can see it is a little bit off right now. So I got to turn off my markers. And let's realign this for the center again. Like so. So that we have it equal on the screen. And we should have, that pip should be right on there when we get it centered properly. Okay, like that. Let's turn the pip on. Just a wee little bit off, see that? But not bad. Oh, this thing's so touchy here. There we go. Not bad though. That should give us a really good audio sound. So there it is. Let me get you straight on so you can see what the finished product looks like. And there it is. Now, that's all there was to it. I mean, all that talking I did, it still only took maybe 5 minutes. And if I shut off my blanking box, you get that ugly line. So, by the way, another note about that, about this retrace signal here. Some oscilloscopes, this one is not one of them, the actual trigger circuit will work still when you're in XY mode. So you can actually use the hold off and some things like that to get rid of this. But on this particular type of scope, this has no influence no matter what you set it to. Nothing works when you're in XY mode. And you'll find a lot of the older analog scopes, you know, will be like that. Now some of the newer digital scopes will still let you use triggering and other methods that you can either reduce or eliminate that, but a lot of the analog scopes you kind of have to have a blanking box if you don't have a signal generator with built-in blanking. Anyway, let's connect up an antenna and see if this thing can tune in some stations. Okay, antenna is connected. See if there's anything. Not getting a whole lot down here. So we only have one strong station down here. A lot of weak stations. So there you go. So now let's look at the method that I prefer to use to the S-curve or the sweep method. We're going to use a non-sweep method. We're just going to use a basic modulated FM signal. And let's see how close I can get it with my technique that's a lot easier and doesn't require any fancy test equipment. Okay, we have a much simpler setup now. So we're still injecting into the input of the IF strip just like I did for the sweep alignment. But now I'm just using my 8657 and I just have 10.7 megahertz carrier frequency, and I have the FM modulation turned on with 400 hertz, and I'm coming out of the record output, or the tape record, you know, where your tape deck would connect, the record out, and going right into my scope, and I'm just looking at the 400 hertz signal. You can see it's 400 hertz, and there it is. Now, I have a pretty strong signal going in there right now so that I can very clearly see that everything's there. And now what I'm going to do is I'm going to reduce this signal a little bit at a time until I start seeing that kind of static on there. All right, and I'm going to change this to make it a little, just change the sample rate. And you can see right now we're getting a little bit of static here, and we're getting a little bit of static up here. Now, here's the thing. With these digital scopes, they're a little bit fussy about stuff like that. And although we can do this alignment with this scope, I like using an analog scope more because I can see the trace. The trace doesn't have any delay because it's not being digitized and put out on on an actual LCD screen. It's actually, the trace is actually moving across the phosphor in real time. So it's a little easier to see this static. Let me show you the difference. So you can see, maybe not to you, but to me, I can see this static a lot better on this type of a scope. But most of you are probably going to have a more modern scope. A lot of people buy the digital scopes. They're very cheap. They can do a lot of things. So I'm going to go back to the digital scope, and we're going to do it with that. Okay, so let's just turn that off. All right, so what I'm going to do is I'm going to keep reducing this until I really get some serious static going on in there. See that? And the first thing I notice is my tuning dial is dead center, which is good. So that means our swept alignment helped us get that perfect. But you can see there's more static on the bottom than there is on the top. You see that? And if you play with the scope a little bit, sometimes it's easier to see when you change the, like that. All right, so what the name of the game is, we want to get this as tall as possible, and we want to maintain this exact same amount of static on the top and on the bottom. So what I'm going to do right now is, and if you listen to the audio, it sounds like that 400 hertz, and you'll hear a bunch of static in the background because we've reduced the signal a whole lot. So okay, so now let's go to our alignments here, and the first thing I want to do is I'm going to go to the back of this. We're going to go do our alignment. Remember, the tuning dial was centered, so that's pretty good. And I'm going to see if I can get the screwdriver to go in again. Okay. And if I adjust this, you can just barely see. Let me see if I can bring this in closer so you can see what I'm doing. It's very subtle. And watch the amplitude of the signal as I go. See how it I go through that peak. Maybe you could see it a little easier this way. See, it's going down, up, down. I pass through it. So we want to just kind of get it centered like that. I'm then going to go to the front here, and I'm going to adjust this just a little bit. And you can see what happens there. I want the static to be totally equal on both sides. You can see it's not right. My FM tuning indicator is off center, so I'm going to center it again. So you can see we're not perfect, but we're going to get there when we do these IFs. It means that one of the IFs is not perfectly centered, so, or not peaked properly. So now let's go to third IF, and I'm going to adjust that. You can see that that brought it in really good there. See that? See how equal it is now? I might even be able to get it a little better. And then I'm going to go down in amplitude even more. And I'm going to increase this. There we go. And you can see now how it's difficult with the scope to see what you need to see. And no matter what I do here, it's kind of not very easy to see. Much easier with an analog scope. All right. So that looks pretty good right there. Okay. Now I'm going to go up a little bit again. And I'm going to go back to the back one. You can see you just kind of go back and forth. And the idea is you want that static to always be centered. You want it to be symmetrical, I should say. So let me see if I can get this. These things are difficult to get the adjuster in there. Okay. I'm going to go through this one and see that definitely made it wrong. So I'm going to go this way. Right there. See how they're both equal? So I'll stop there. Now I'll go to second IF. And there's the peak right there. You can see as I get close to it, it really gets active. Okay, and then I'll do this one. And you can see when I came out of that last one, it moved a little bit, so we have to readjust it. That adjustment is a little bit. Let me go back, because something moved on us. There we go. Okay. All right. And now we go to first IF. And see, the idea is you just go back and forth. We want to peak this as much as possible. And sometimes the highest amplitude isn't going to give you the best symmetry. You might be a wee little bit off. And that's where we want to kind of compromise a little bit. That looks good there. Because really, you're going to sacrifice a teeny tiny little bit of sensitivity to get better sound, if that makes sense. All right, last one. That's the wrong way. Okay, so that one was right on. So all of them were very, very, very close. So you can use the sweep method or this way I'm doing it. And that's it. So when you're done, you should just see a little bit of static here and, you know, at the bottom and the top of the waveform, and it should be symmetrical. And it means that you have everything centered. And the other thing is you want this to be as high of an amplitude as you can get, But as I said, you may have to trade off a wee little bit of amplitude to get it the symmetry where you want it. So let's see if we got it right that way. I'll try to tune again and see if it's probably going to be the same because I didn't move it very much at all. Okay. Don't want to stay on any song for very long. Good.
Day, July 31st.
Like I said, down here where I live, we don't have a lot of FM stations. Pittsburgh's just kind of is about an hour south of us. And
why wouldn't any of us draw that? Because we conceive of the...
Pittsburgh's about an hour south of us, and being down at the bottom of a hill, I have two kind of little hills on either side of where I live, and it makes it really difficult for line of sight for FM reception. But that's about all I can do. But it is, you know, it's typical of this type of tuner down here. It's perfect. So there you go. That's pretty much, again, how to do an FM alignment. I get a lot of questions about it, and that's pretty much how you do it. Now, to do the dial accuracy, it's pretty simple. You're going to inject an FM signal, modulated signal, into the antenna, just like you're going to tune in a station, and you're going to set it at, it's in the instructions here, they're going to set it to 90 megahertz and 106 megahertz. And basically you're going to set it on frequency here and then set it on frequency here. So the low frequency band, or low side of the dial, you're going to use the coils and the transformers. And for the high frequency side of the dial, you're going to use the capacitors, the tuning capacitors. And they're all over here. You can see them right here. So you have a couple of them in here, and then these two of these are for the FM, and then two of them are for the AM. So basically it's the same thing as the AM alignment that we did earlier, where you're going to set your oscillator and then set your dial accuracy. So I'm not going to go through that again. You saw that on the AM portion. If you notice this other step I kind of skipped, if you have a distortion meter, which we do, you can actually inject a 98 megahertz carrier with your modulation on it, and you can feed that out of the tape record jack into your distortion meter, and you can touch those up to minimize the distortion. And remember when I told you about we were setting that static at the top and the bottom? If you get it perfect like that, like we did, you will null out your distortion. You'll have the minimum distortion you can get. And so if you don't want to use the static method that I did, you can use a distortion meter and tune for minimum distortion. And what you'll find is when you set a low signal, you'll get that static at the top and the bottom peak that'll be symmetrical, indicating you have lowest distortion. But again, it's up to you. I'm trying to show you different ways to do this because everybody has different test equipment on their bench, and there is no one way you have to do it. There's other ways. Some can be a little easier or maybe a little more accurate than others, but there's plenty of ways to do an FM alignment. It's not that difficult if you start to understand how it works. Now, unfortunately, to do the stereo multiplex alignment, it's super easy, but you have to have the test equipment. There is no other way to do it. I mean, you can kind of work off of a strong FM signal, but I really don't trust that very much. It's better to have the actual signal generator. And if you look, so I have the SG80 set to multiplex. That's going to be your stereo. I have it set to stereo right now and 400 hertz. And your modulation, you know, it'd be up 80–90%, something like that. Okay, as you can see, I'm injecting my multiplex signal right into the input of the multiplex board, which, remember from our FM alignment, our IF alignment, is this yellow wire, and that is your detected audio output that goes into the multiplex input. So this is your IF detected audio input. So we're going to just feed that multiplex signal in there. And if you look up on the scope, I'm looking at the record output jacks for left and right. You can see we have our 400 hertz signal. Now, what we want to do is we want to adjust the pilot and everything, and we can do that with no audio. So if I turn the audio off, like that, and you can see that's this right here, I turned it off. Now all we're doing is we're just putting a pilot signal in there. See, normally you would have your pilot signal set to 100% modulation, but you can see that's 9%, and the instructions want you to set it for 2 to 5%. So I'm going to turn this down, set it to about 3%. How's that? Okay, and I'm going to go now to mono. There's no modulation. If I go down and look at my stereo indicator, there it is. When I go from mono to stereo, it detects it. So that means it's set. Okay, and basically what they're doing is you're going to use L301, 302, and 303, which are these three little coils here. Let me get you zoomed in here better. These three coils here, here, and here, you're going to adjust those to get the maximum amplitude on the scope with pilot signal only. So, and you're going to go to test point number 6 on the multiplex board with your scope. So right there's test point 6. Connect our scope. I'm going to use the analog scope because I don't want to mess up the other scope because it's set to the audio output. And all we're going to do is adjust L301, 302, and 303 for maximum amplitude. So here they are. And that was right on. That was a little bit off, but we may end up bringing it back. And then this one here is perfect. Okay, so they're all good. Then we're going to go to 5%. So I'm going to turn up the modulation a little bit till we get to 5%, like that. And we want to make sure that our stereo beacon is on, and it is. See that? Now, we can play around with the pot until it comes on, but it's set. I'm not going to mess with it. Basically, you're going to turn the pot down till it drops out, turn it on till it just comes on. And you're going to find out you may have to play with that pilot detect a little bit, depending on the area where you live, because you may not want it to be as sensitive, because you may not want it always to switch to stereo on a weak signal because you'll get a lot of static. Of course, you could hit mono and disable it, but I'll leave that up to you. But that's how the instructions want you to do it. The next thing, we're going to go to our left and right channel, and that's pretty easy to deal with. And I want you to notice that take note that there is a typo in here. This is not L302, it should be R302, and I will write that on there so we don't get confused. For some reason they just put L in there, but it should be R302, which is the stereo separation pot. Separation pot is here, and the stereo detect pot is up here, just so you know. And so now we're going to go to modulation 400 hertz, and you're going to see you have that there. And all I'm going to do is I'm going to adjust this pot down here if we need to. So let's go to right channel, and you can see how this is a little bit of a wavy line. So what I want to do is I want to adjust that pot until I get rid and I'm turning the wrong pot. My fault. Swap those two pots around. the stereo threshold is the one on the left there, and the pot sitting at the top of the board is the separation pot. And there you go, see it? And that's about as close as I can get it. Right there. And let's go to right channel or left channel. And again, it's pretty flat. And that pot is almost maxed out in one direction. And there we go. Right, left. That's it. Now if I turn my signal up real high, you can see it can't completely get rid of it, but that's just the way the circuit works. But it's good. We can get it pretty flat. Okay, so I cleaned up the case and put a coat of Howard's Restore on it, and I cannot believe how pristine it turned out. This is a really beautiful looking receiver. Now again, these are a little bit overrated. I think they rated them at like 40 some watts per channel, but this is really more of a 30 watt per channel amp. And we'll take a look here. Okay, I'm not sure if the meter face is all washed out with the light, but hopefully we can see. So we have our 1 kilohertz signal, and we'll bring this up, and that's a beautiful looking sine wave. And look at our distortion. Right there's clipping. If I drop it just below that, it's about 0.067 THD. That's not bad. And we're getting about 15 volts RMS. When I start getting up to that, right where it's starting to clip, yeah, it's about a 30 watt amp, give or take, 28 to 30 watts per channel. Now here's the thing, if you look at the waveform, there's a telltale sign that this amp could actually have a little better output. See what's happening? See how that jitters at the top and the bottom? That jittering is happening at about 60 hertz. And that tells me that what's happening is the transformer is kind of loading down. It's sagging. And if you remember when we looked at this thing, the transformer was very small for being a 40 watt per channel amplifier. And that's the problem. Now, we might be able to put a larger set of capacitors in there, and that would help a little bit. But all in all, you really need to have a bigger transformer. If you had just a slightly bigger transformer, same voltage, just a higher VA rating, this amp would easily be a 40 or 45 watt per channel amplifier. But that's just kind of the way it is. Now, maybe if this thing were wired for 230, European power, maybe, I don't know, but the iron just isn't there. But it is a really clean sounding amp. I mean, you can see there, we're running it at about 10 volts RMS right there. So like as a 20 watt per channel amp, this thing's beautiful. I mean, really clean sounding. So I think it'll be a good receiver. Now I can do all the frequency sweeps and all that. I'm not going to, I have so much time in this video already. We'll just close out by listening to how it sounds. And I have a new little device I built, It's down here. This little gray box back here. You can't really see it too well. And what it's going to allow us to do is you're going to listen to exactly what the signal is that's in the speakers, that's going into the speakers. Now, of course, you can't hear sound pressure waves that I'm hearing here from my speakers, but any type of a load that the speakers are presenting to the amplifier and whatever's happening to the signal, it's going to track perfectly, and this is going to get directly piped into the camera, into the audio of the camera. So you should be able to hear the closest facsimile of what this amp sounds like as we can possibly do with a recorded video online. So let me know in the comments how it sounds. Well, what did you think? I'm going to have to check this out when I get it up there to edit it, because I think I might have had the record level set a wee little bit too high. It might have been clipping a little bit on the camera, but I don't know. That's why I kind of turned the volume down slowly at the end of the sample there so we can see if it's straightened out. But anyway, let me know what you think of this, because this is kind of a little invention of mine. I don't think anybody has ever done anything like this. And I don't know if it works out. We'll have a good way to demo amplifiers on this from now on. So anyway, that's the end of this really, really long video. And as always, I wish you all peace, joy, happiness, and good health in your lives. And I'm really looking forward to working with you again soon on the next project. And there's so many, I don't know which one I want to do yet. But I don't know, whatever the spirit moves me to do, I guess, huh? That's what my mom used to say. Anyway, take care, everybody. Bye-bye.